uh, something about yarn. Okay, so any questions with the HDFS or the installation, or shall we move? Anything anything related with the HDFS? Are we good with the HDFS? Yeah.
Regarding the installation, like can you just again it would be can you briefly tell like what are the softwares we need to install to get started to get a minimum hands-on, like what will be the softwares we need to install, like you told Oracle VM box and then a Cloudera.
Yes.
Can you come again on that? Just brief.
Yeah, so I'm giving you this link. You can directly install this link. A virtual box is required. So let me put it in the chat box. So you have to install this virtual box. And second thing is you need to install a Cloudera this VM, this particular sandbox. Okay, so for getting a sandbox, I'm giving you a link. You can just get it now. It will ask you to give some details and then it will start the download. So I'm just giving you one link which you can try out. This is the latest one available. Okay, but it's not necessary that you always go with the latest one. You can go with the older version also. So only these two things require, nothing else.
Dheeraj, like when you went to the command line prompt, what is the username, password, or something that you use it to log in?
From the command to log in into this particular server.
Yes, once you install it and you went into this, command line prompt,
Cloudera,
there should be some username, password, right? Yeah, like Unix username, password, or something.
Cloudera.
Oh, Cloudera. Okay. Okay.
Okay.
And Dheeraj, one more question. Like we create a file here, can we import a file from from our Windows where we have to into this sandbox into this HDFS?
Yes, we can do that. So let's say I want to upload a file. Okay, but let me show you. So let's say instead of doing all of that, what I will do is simply I will go to this folder. Okay, in this folder I will click on this upload. I want to upload a file, so click on the file. It is saying select a file. So selecting a file is like directly go and then choose anyone from our desktop, and then we can upload directly over there.
Thanks, Dheeraj.
Okay, let's say if you want to create a directory, so over here it gives different options like new. You want to create a file or directory, you can choose that and it will create it for you. So if a directory or a file, that option is there. So you has all of that option. If you find it difficult to remember those commands, HDFS commands, you can do it from here as well. But always the recommendation is to always follow the command line, right? Because that's where you get more practice and you get more confidence to work with this. So always I would suggest to directly go to the command line and work from the command line, right? Use all of these type of options like mkdir, copy from local. There is one more option, let me show you. So HDFS DFS hyphen put is also one option. Let's say I want to put this entire directory. I have a lib directory, right? I want to put this entire lib directory in user Cloudera Sprintzeal, right? So put will move the entire directory and all its content into HDFS directory like this. And so I'll try to explore all this type of different options that we have.
When the injection tools will come into picture at this point of time?
Ingestion tools will come into picture at this time. Yes, you're right. So oh sorry. So when you are doing all of this operation like put and all, it is not internally invoking an ingestion tool. It is simply moving a file from local file system to the HDFS. Right? The ingestion tool will come to picture if you are running some of the ingestion tools like Scoop or Flume, then those things will come into picture. So whatever we are doing now, it's not calling any of the ingestion tools. These are some operations which we are doing using the HDFS. Okay, some HDFS commands we are trying all that.
Okay.
So once we learn about the ingestion tools, we'll see like how to invoke them. But these are just some basic HDFS interaction with using the command line. Okay, so somebody was asking like once it is downloaded, what to do next. So you just have to double click on this file. Okay, and once you double click, it will automatically give you the prompt what has to be done next. See, once you double click, it will say what you want to do, and then you click on import. Okay, so once you double click, this window will come up. Once you click on import, it will start importing that particular VM into your virtual box, and then you can just say start. Okay, so once you click on import, it will start importing. It will take some 5-10 minutes, and once that is imported, you will get an icon like this. And after that, you have to just select that icon and then click on start. It will start a VM machine like this. Okay,
What about other option, Cloud Apache and these are?
other option is you have other option which is known as Hortonworks. You can try that as well. That's also very popular, and that's also similar.
In Cloudera itself, means there are other option also, Cloudera Apache.
No. There is nothing called Cloudera Apache. See, Apache is kind of an open source community of multiple softwares. Okay, Hadoop is a part of. Okay, let me first tell you what is the difference between all of this. Okay, Hadoop, this is the open source software. Okay, open source software under Apache. Okay, so once you create an open source, you have to make it available with some licensing, which is it comes with the Apache license. Okay, most of the open source tools comes with the Apache license. So once you have something in the open source, this entire Hadoop is an open source. Now what happened, people started commercializing and to distribute it, right? So there are companies like Cloudera, Hortonworks, right, Mapr and IBM, Microsoft, a lot of Oracle. What these companies are doing, they are taking this open source Hadoop and then they are creating their own product like this on top of the by using this software, and then they are selling it. Okay, so all of these things are commercial product of an open source version. So whatever you have, so the way they make their business is this Hadoop is open source. They are adding all the components of this in their Cloudera, and then they are adding some more components and selling it. Like for example, this is Cloudera, right? This is Cloudera. So in this Cloudera, there are some components which are like Cloudera Manager. Okay, so Cloudera manages Cloudera's proprietary software, which is used to manage the entire cluster. This is not open source. This is Cloudera's proprietary software. So what they are saying is, in order to commercialize this Hadoop, they are embedding everything, all the open source components, adding some of their uh, paid versions of things, and then they are selling it. So similarly, Hortonworks also do the same thing. IBM, Cloudera, Oracle, all of these things do almost similar kind of business. Okay, Apache is a open source distribution of the software. Okay, there's nothing called Cloudera Apache. Okay, there's called Cloudera Hadoop, which is using Apache's distribution. Okay, am I clear?
Yes. Actually, I saw that one option in that command box, Cloudera. Sorry, not command box. Can you go back to the Cloudera screen? Not here. Second one. Yes, here. Oh, sorry, CentOS Apache. Okay.
Yeah, this is different.
Okay. So we need to go through this Cloudera quick start, right?
Yes.
Okay.
Okay. So let's talk about Yarn now. So yesterday we discussed like Yarn is yet another resource negotiator. Okay. So the reason why it came into picture was because in Hadoop 1, the job tracker was a single point of failure and it was not able to handle a lot of the things which a yarn can handle. Let me quickly brief you about that. Okay, so in Hadoop 1, there were some issues. Okay, what are those type of issues? The first issue was like the job tracker was a single point of contact for a lot of things. Like it was handling all the clients, it was handling all the task tracker, it was handling all the tasks. So everything was done by the job tracker and it was kind of a bottlenecked process. Right, so once it was bottlenecked, there were some limitations. Right, so these are some of the limitations. The scalability was limited to only 4,000 nodes. Right, we were not able to span the cluster more than 4,000 nodes because it was not sustaining. It was not sustainable. Okay, the maximum number of concurrent tasks which could run in Hadoop 1 was limited to only 40,000. Okay, and then the second challenge was it was a single point of failure, which means if job tracker is down, you cannot do anything. It's like almost everything is gone. Okay, and then there was no scalability. Name node, there was no high availability for the name node, overburdened job tracker. So all of these issues, to handle all of this issue, they reinvented the architecture of the way data should get processed, and they come up with this concept of yet another resource negotiator. So YARN, this YARN is yet another resource negotiator. So what they are doing is they are saying, okay, job tracker was overburdened. So what I'm going to do, I'm going to split the responsibility of the job tracker into two separate processes. Right, so there were two things job tracker was doing. The first thing it was doing was resource management. Okay, and second thing was the application monitoring. So these were the two major responsibilities of the job tracker. Resource management means like which task has to run on which node is having how much of capacity, right? So those type of resource management was handled by the job tracker. And second thing was application monitoring, like how many tasks are successfully running, how many of them are successfully completed, how many of them are not at all running. So these two types of the work are the major responsibilities, and since it was necessary to split into two separate processes. So they come up with the idea of a global resource manager and application master. Okay, so entire resource management, which node is having how much of free resources, entire resource management, it's simply just take the example of a project. Okay, so usually a resource manager, let's say there's a resource manager. Usually a project will have a resource manager who takes care of all the resourcing, right? All the hiring process, which resource is allocated, how much, what is the bandwidth of each of them, and how to get all the resources, where to put all of them, leave management, all of those type of things, right? And then there will be some another person, maybe team lead or somebody, who will look into the deeper dive into each of the tasks, like how is the task getting completed, whether the tasks are getting completed or not in time, whether coding is happening or not, what are the issues with the project, how many escalations are there, right? So these two responsibility, usually in our project also, two separate people handle this, right? The person who is handling all the technical issues, he is not most of the time he is not responsible for all the resource management. Resource management handled by the resource manager, right? So similarly, in the Hadoop yarn architecture also, the resource management is separated by introducing a global resource manager. Is kind of an HR kind of person, right? Or maybe some resource manager, or and the application master is responsible to perform the execution of the task and to ensure a particular job is running without any issues. Okay, application master. Now there is one more thing. Let's say earlier in the earlier version, job tracker was responsible to do all the one job tracker was responsible to handle all the requests. Like over here, if there are client one submitting a job, it will go to job tracker. Client two submitting job two, it will go to job tracker. So all the job intake request was going to one job tracker. In the yarn, what they have done, they have splitted up one job, one application master per job. Okay, it's like uh, one project manager for each project, right? If I have 100 projects, all the project management should not go to one manager, right? So each project will have their own project manager. Similarly, in application master, each job will have their own application master, which will look into the application status, like how many tasks are started, how many of them are running, how many of them are failed, all of those type of things. Okay, and then there is another component which is known as a task tracker. So task tracker is kind of a slave, right? Its responsibility is usually to run the task. Whatever request comes from the master, just run that. And node manager is there, which is again similar to uh, a process which takes care of uh, node label resource management. Okay, so if this is a master, if global resource manager is a master, then this one is a slave. Okay, if application master is the master, then task tracker is the slave. So that's how a master slave architecture is there.